So let us review what we learned before when it comes to the definite integral. Suppose I ask you to calculate the following integrals. We're going to start by calculating a very simple integral that you saw before. So, for example, what is the integral of dx? When you're calculating the integral of dx, the variable that you're using is x itself. It means that the function that you had was 1 times dx. This integral is equal to x plus the constant of integration. Why is that? If you take the derivative of x plus c, it must be equals to this function that is inside your integral. What is the derivative of x plus c? The derivative of x plus c is 1 plus 0 or just 1. So is this equal to the function inside your integral? They are the same thing. So it means that the integral of 1 dx is equal to indeed x plus c. Now the question is, what if you want to calculate the definite integral? What is the definite integral of a to b of dx? This is basically saying that, hey, I have x plus c, then I'm going to substitute b, substitute a, and do the subtraction. So this is x plus c as x ranges between a to b. If you plug in b, you get b plus c minus, if you plug in a, remember that you have a binomial, you have a plus c. So if you distribute negative sign into parentheses, you get b plus c minus a minus c, and as you can see, the constant of integration disappears, all right? So you get b minus a as the result of this definite integral. So this is the simplest integral that you have. The integral of 1 dx, the definite form, indefinite form. And I expect you to ask, what if I change this variable? What happens if I change this variable? What do I mean by that? For example, if I ask you to find the integral of dt, what is your answer? The integral of dt, it says, hey, the function inside the integral is still 1, but now we are taking the integral with respect to variable t, which in turns is equal to t plus c. What if we have the definite integral of du, a general variable like u? The same process, it is u plus c. You can basically take the derivative of the right-hand side and show that that derivative is equal to 1. We can make it more interesting. Like what? We can basically say that now what if I take the integral of 2 dx? What happens there? So if you have the integral of 2 dx, first of all, 2 as a number can be written in front of the integral. You have 2 integral of dx. But the integral of dx, we saw this. We know how to calculate the integral of dx. This is basically equals to 2x plus, you might say, hey, I can distribute 2 into parentheses and I can write it as 2c. But 2c is another constant. It's another value that is fixed. So call it c. Now, what if we want to calculate the definite integral of 2 dx? The definite integral of a to b 2 dx is equal to 2 times x as x ranges between a to b, which is basically 2b minus 2a, or if you factor out 2, you get b minus a back, right? Differentiate between the definite integral and indefinite integral, right? There we go. Simplest integral possible. So as we introduce new topic, new contents, we're going to go over basic definitions. So in general, you might say, hey, what if this 2 is any coefficient, any number? What if I have a general form like this? I have the integral of k dx, x ranges between a to b. What is this integral? This integral is k times x, x ranges between a to b, which can be written as k b minus k a, or if you factor out k, b minus a. So generally, you can just write the integral of any number multiplied by dx. And then for dx, you can switch it by dt or du. It doesn't change the fact, it doesn't change the process. You only change the variable here.